Hey guys, just a couple quick examples on section 8 from chapter 5. We're just going to cover a couple of the last sections and then take a little quiz over them. This is called curve fitting. We did it with linear functions. So this slide, let's just talk about it for a minute. So if you remember, we can use what we call differences. They call them finite differences in a set of data. And differences is just subtracting numbers, right? To figure out what the patterns are in the data. And if the first set of differences, let's look at the blue font here, if the first set of differences in the y values, remember y is f of x, if the first set of differences in the y values when you subtract them, 4 minus 9, we went down 5 from 9 to 4, we went down 3 from 4 to 1, etc. Notice that these numbers are not constant, okay? So obviously we don't have a line. The first differences are lines. The second differences, however, for this function, if we take the blue numbers here and subtract those numbers, we go up 2 every time. And you can see that we have constant differences in the y values. And this function is actually the parent function for a parabola, or x squared. So that's how you know. One other thing to point out, you should glance at the x values and make sure they're equally spaced. I'm not going to give you any that aren't, because we're just going to barely cover this, but you should glance at the x values, make sure that they're equally spaced, and then calculate the first differences for the y values and then the second differences. And you're just evaluating the second differences to see if it's a quadratic function. So let's try one. Let's determine whether this set of data could represent a quadratic function by looking at the differences. Let's start by evaluating the x's. We notice that we go up 2 every time for the x's, so those are equally spaced. Now we're going to create 2 lines down here quickly. The first one is going to be subtracting the y values, okay? From -1 to 1 we go up 2, then up 6, then up 10, then up 14, okay? If you want to do this, you're going to start with the right value and subtract the left value. 1 minus a -1. Okay? Imagine you're on the number line. You start at -1. How far do you go? You go up 2. You start at 1, you go to 7, you go up 6. Okay, this is just telling us that these numbers are not the same. They're not constant, so we don't have a linear function. So we're going to do the same thing, go through it again, subtract the numbers in blue here. So 6 minus 2 is 4. 10 minus 6 is 4, and 14 minus 10 is also 4. So our second differences are constant, so yes, we do have a quadratic function. Example 1b, again, we notice that the x values are equally spaced, and we're going to subtract the y values. 3 minus 1 is 2, 9 minus 3 is 6, etc. Our first set of values look like this. And we're going to take those numbers, the blue numbers, and we're going to subtract those. 6 minus 2 is 4, 18 minus 6 is 12, etc. And we end up getting not constant numbers, okay? So this is not a quadratic function. That's all you have to do. You got to show me the second differences and say not. Let's do one more. These numbers go up by 1 here. In the y values, let's evaluate the first differences. 21 minus 11 is 10. 35 minus 21 is 14, etc. We have these numbers here for our first set of data. Our second differences are up by 4 every time, so obviously we have a quadratic function. Okay, that's it for this. We're going to practice this tomorrow in class. Make sure that you have your notes. Have a good night.